Hey guys, today we're going to be doing a little chemical experiment involving a very strong chemical base and some aluminum foil. We're going to be putting them together and putting the off-gas hydrogen in a balloon and blowing it up. So here in this bottle on the left we've got some water, and we'll be adding some caustic soda beans. This is sodium hydroxide. This is the base we're going to be using. And in this highly caustic base, we're going to be adding little rolled up pieces of aluminum, and these will essentially dissolve in this base and off-gas hydrogen. So when this hydrogen is off-gassed, it's going to come up, build pressure, and go through this little tube connecting these two bottles, and then it's going to go down into below the water level to cool off any steam, any moisture that might come along with it. And then the hydrogen is going to bubble up out of the water and build up in this little balloon right here. And then we're going to detach the balloon and blow it up. Okay, so now we're outside and we've got all of our things put together. Now all we have to do is get the base in the bottle and start up the chemical reaction. So we're going to take these little caustic beads and put them in about 200 milliliters of water. We're going to want to do it very carefully using a funnel, because if any extra beads fall out, we are going to want to, it would not be good. Don't let any beads fall out if you're reproducing this. Also be very careful because there is a static charge, and some of it will cling to the spoon. So you are going to want to throw away the funnel and the spoon after using them. Also, just the little amount of chemicals that are in this tap water in this bottle is starting to make this base act up. So it's already lukewarm because this is an exothermic reaction, but it'll get a lot hotter really soon. Okay, so we have our base made. Now it's time to add the aluminum. It will take a while for this reaction to get going. Since it's an exothermic reaction, it works better when it's hot, so it will gradually speed up. We're going to put the stopper on immediately to capture the off-gassed hydrogen. Again, this will take a little bit, but we're already starting to see a couple bubbles form. Alright, so the aluminum is starting to dissolve. You can see the bubbles coming off of it. That indicates that the NaOH, sodium hydroxide, is breaking down the aluminum and off-gassing hydrogen. Our little balloon is starting to get some hydrogen gas in it. When we started off this experiment, there was some oxygen, normal atmosphere air in the tube and in the bottles, and we did that so that we'll get a little bit of a pop when we ignite the balloon later on. So when this reaction is finished, in this bottle on the left we will have something called sodium aluminate hydrated. Basically it's the aluminum that's been hydrated. We used to have NaOH, which is sodium hydroxide, but we took the hydrogen out of it. Now we have sodium aluminate, and the aluminum has been dissolved down, or that's what the hydrated means, and that's how we've got the hydrogen to come out and go into the balloon. Okay, so now what I'm going to do is I'm going to give you a close-up of the aluminum, since the base has really started to do some work on the aluminum. And so let me get a little bit closer. You can see that it's bubbling very rapidly now. So since this reaction has started getting very quick, we can see that the hydrogen is coming out at a very fast pace. The bubbles are very frequent, but over here on this side you'll notice that the water is no longer clear. This is because the aluminum has been oxidized or hydrated, and this is the broken up aluminum that is staying inside of the base. So this is an exothermic reaction, so this water is actually really close to boiling temperature, about 200 degrees. Um, and so as I told you, as it gets hotter, it gets faster. So these bubbles are coming out very quickly and inflating our balloon very rapidly. Our aluminum is nearly all the way dissolved, so the reaction has slowed down quite noticeably, and the hydrogen bubbles that are coming up on the other side, on the other flask, are not coming up quite as quickly. Something I forgot to tell you a while back is these flasks are built to handle the heat, so they will not break under all this heat. Now this balloon, we're going to be igniting it to test if it's hydrogen. Another way to test if it's either hydrogen or helium is to let go of it, and if it floats away, it's one of the two, because both of them are lighter than air, oxygen. But by igniting it, and if it ignites into a ball of flame, it will prove that it is in fact hydrogen inside of the balloon. Right, so now it's time to detach the balloon. To do this, if you are recreating this, pinch the balloon right at the end, close to the stopper, so hydrogen builds up between the stopper and the balloon, so it will be easier to remove. Then just simply pull it off the stopper. You're going to want to tie it off, but if you are igniting it, I would recommend doing it within 3 hours, because since hydrogen is such a small atom, it will easily float through the rubber. As you can see, it can float, so it's either hydrogen or helium, but again, hydrogen is the smallest atom. It will easily go through any normal balloon, unless you get a high quality balloon that are thicker. Those ones will last quite a bit longer. Scientists repeat their experiments a couple times, so we've put on a second balloon, and you can see that the reaction is going quite a bit faster because we've put in the aluminum, and the liquid inside is already very hot. So you can see that right there. We just put it in, and already the hydrogen is coming out very quickly. The balloon has already inflated to about half of the size. Now here the reaction has slowed down. That's because all the caustic base is about used up as for breaking up the aluminum in the last experiment. So if you are going to do more than one balloon, you might want to do a little bit more caustic base in your reaction.
Whoa! That was awesome!
Okay, so the experiment was a success. Both balloons exploded into a ball of flame. This proves that they are, in fact, both hydrogen. Now, the reason that they explode into a ball of flame is because it's the hydrogen bonding in the air with oxygen. This is creating water. Now, if this reaction had a perfect mix of hydrogen and oxygen, the explosion would be supersonic, a little bit louder than your average shotgun. This is because there is the perfect bond between the hydrogen and oxygen, making it a wonderful explosion.